Hello everyone, welcome to YourPedia Education. Today we are going to discuss the questions from communication system. If you are going for BEL exam, so these questions are important. You have to go through these questions. So today we are going through around 109 questions are there, and we are discussing these questions. These are related to BEL, right, and it is from the communication system. So if you are preparing for BEL, these are very important questions. So let us start from the first question. Which of the following is considered the primary function of a transmitter in a communication system? In a communication system, if you are going for the block diagram of a communication system, there are two things. One is transmitter, another one is receiver, right? Transmitter means which convert the information that will be a message signal, that convert the information in the form of that we can transmit through a antenna. So we can say what? It convert the message signal into a suitable form for the transmission. When you are transmitting that signal, right, basically what we have to do, we have to convert that signal into a high frequency signal, because message signal is a low frequency signal. That process is done by a modulator. So basically modulator do low frequency to high frequency conversion. So that is a transmitter. So what is the main function of transmitter? Converting the message signal into a suitable form of transmission. Answer will be B. The communication system, which component is responsible for adding noise to the transmitted signal? See, basically if we talk about the noise will be added to your signal whenever it is transmitted through the channel. See, in the block diagram we have transmitter, we have a receiver on the other side. So in between these two, transmitter and receiver, we have a medium. Through that medium your message signal will, or your signal will be passed. That medium is called as channel. So basically that is responsible for adding the noise, that is called channel. What is the primary purpose of modulation in communication signal? See, whenever we are discussing about the modulation is a process to convert a low pass or low frequency signal into a high frequency signal. So modulation is what? That is a process to convert a low frequency or shift the baseband signal. Low frequency signal are always called as baseband signal. So it converts the baseband signal into a high frequency signal, right? High frequency for transmission. Okay, next. Which element of communication system is responsible for recovering the original message signal from the received signal? See, that part will be done at the receiver side. So receiver will done that thing. Receiver will convert your recover the original signal from the received signal. That will be a receiver. Next, which of the following is an example of guided communication channel? There are several type of communication channel. One is guided. In guided we have waveguide, optical fiber, and non-guided medium is free space. Radio wave communication is non-guiding, right? And free space communication is also non-guided. Satellite communication, we are not providing any guided medium to them. So these are the non-guided medium. Only optical fiber is a guided medium here, right? The amplitude modulation, which parameter of the carrier wave is varied according to the message signal? So in this one we have AM signal, the parameter which of the carrier frequencies varied according to message signal. The amplitude will vary according to the message signal, right? The amplitude of the carrier the carrier signal will vary according to the amplitude of the message signal, right? The bandwidth required for an amplitude modulated signal is equals to the, see, if we are talking about the amplitude modulated signal, the bandwidth of the amplitude modulated signal is twice of the message signal frequency. The bandwidth of AM signal, twice of FM, twice of the message signal frequency. So what will be the answer? B, twice the modulating signal frequency, right? Next. If the carrier frequency is 1 megahertz, the highest modulating frequency is 5 kilohertz. What is the bandwidth of AM signal? See, this is the carrier frequency, this is the message signal frequency. So I already told about this thing. Whenever we are talking about the bandwidth of the AM signal will not depend on the carrier frequency, it is depend on the message signal frequency. So twice of FM, right? So it's going to be 2 times 5, that will be 10 kilohertz. Next, what is the modulation index of in AM if the maximum and minimum amplitude of modulated wave are 10 and 66? See, basically when you are going for the amplitude modulation, the waveform of the amplitude modulated signal is look like this. This is your amplitude modulated signal. This is your maximum A max or V max. This is your minimum V min. So what is given to you, A max or V max? Let us take A max. A max is given to you 10 or V mean is given to you, sorry, A mean is given to you 6. So modulation index is generally defined as maximum minus minimum divided by maximum plus minimum. So that will be 10 minus 6 divided by 10 plus 6. It is going to be 10 minus 6 is 4 divided by 16. That will be 1 by 4. It is 0.25. So the answer will be 0.25. So it should be 0.25. A answer, right? Yes, misprint here. That is not 0.4. That is 0.25. Okay, next. If a AM signal, in a AM signal, what percentage of total power is contained in a carrier if the modulation index is 0.6? See, basically if I am talking about the AM signal, the total power, total transmitted power is how much? PC 1 plus M square. M, either you can take M or either you can take mu, right? It is both the same thing. That is called modulation index, right? So this is the total power transmitted. Inside this total power, this PC is your carrier power. So total percentage of power contained in the carrier power divided by total power multiplied by 100. So whenever you put the total power in the denominator, PC will cancel out. So what will we got? 1 over 1 plus M square by 2 into 100. And whenever you put in place of M, we just put the given modulation index, that is 0.6, and when you solve it, you will got that it is around 64%, right? So that is the main reason why we are not using the AM signal. See, basically if you talk about the AM, if we are wasting our power in the carrier form, maximum power is carried by your carrier signal, not by the sidebands, because the information is carrying by the sideband in AM signal. That is the major disadvantage of AM signal, that its maximum power is wastage for us, because it is no use for us. Why? Because it is carried in the carrier part, that is not carrying any information, right? Okay, next, the DSB-SC modulated system, what to the carrier component in the transmitted signal. Okay, what happened to the carrier component in transmitted signal? See, if I compare the DSB-SC with full AM, you have a full AM and you have a DSB-SC. What is the equation of full AM? That is, let us take SAMT. SAMT what? Carrier plus Ka time message signal multiplied by carrier. And in DSB-SC, DSBT, we just remove this carrier. So what we got? MT into CT. So what happened to your carrier? We suppress this carrier. So we fully transmitted along with the sideband? No. It partially suppressed? No, it is completely suppressed. So we suppress the carrier, right? So remember that thing. If you compare with AM and DSB, we suppress the carrier completely, right? Then we will go to the DSB signal. The bandwidth requirement for DSB-SC modulation. See, if I am talking about the bandwidth requirement of DSB-SC, the bandwidth requirement is the same as the AM signal, right? So its bandwidth is same as the AM bandwidth, that will be twice of FM, the maximum signal frequency. So what we can say, twice the modulating signal bandwidth, that is the bandwidth of the DSB-SC signal. Next, what is the advantage of DSB-SC modulation over conventional AM? See, this basically I already told you that when we remove the carrier, it means When you remove the carrier, it means what happened? The carrier, the power consumption of the DSB is lesser than the AM signal, because the maximum power is carried by the carrier part. So what we can say, lower the bandwidth requirement is same, lower power consumption due to no carrier transmission. This will be the answer, because we can remove the carrier, so the low power consumption, because we have removed the carrier. Maximum power in AM is carried by the carrier part, right? Okay, next. Which demodulation technique is commonly used in DSB-SC? Basically, if I am talking about DSB-SC, we generally use coherent detection, right? In DSB-SC, envelope detector is only applicable for the AM, full AM detection, and full AM detection you have to choose the mu value less than 1. That you can use the envelope detector, otherwise you can't use the envelope detector. That frequency discrimination method is not used here, peak detector is not here, only the coherent detector is used here, right? If the modulating signal frequency is 5 kHz, the carrier frequency is 100 kHz, what are the frequency present in the DSB-SC signal? See, if you draw the, I'm only drawing the positive side, not the negative side. I'm drawing only the positive frequency spectrum of a DSB signal. DSB signal, we have FC plus FM, 2 impulses, and other impulses is FC minus FM. So FC plus FM is how much? FC is 100, FM is 5, right? FM is 5, so what will be the lower frequency? That is 95, and this one is 105. So what are the frequencies? 100, 95 and 105. Answer is B. So whenever you are trying to find the frequency component present in DSB-SC, you have to draw the spectrum like this, and you will got that there is only 2 frequencies. One frequency is 95, another frequency is 105. What is the primary advantage of SSB modulation over conventional AM? See, whenever we are talking about the SSB modulation, in the previous case I draw the spectrum of DSB signal. This is FC minus FM, this is FC plus FM. So this FC plus FM is called as upper sideband. This FC minus FM is called as lower sideband. So whenever we are discussing about the SSB signal, either we can transmit only the upper sideband, or either we can transmit the lower sideband, right? So if I am talking about the primary advantage of SSB modulation over conventional AM and DSB, its bandwidth requirement is half. First thing, its bandwidth requirement is half, because we are transmitting only one sideband, not both of the sideband. We are transmitting only single sideband. If you are transmitting single sideband, the power consumption is also low. So what we can say, reduce the power and the bandwidth requirement. So it is the requirement of the bandwidth and power is lesser in SSB modulation as compared to DSB and AM. If the original massive signal have the bandwidth of 4 kHz, what will be the bandwidth of SSB signal? Remember one thing, when you are calculating the bandwidth of SSB signal, it is equals to the massive signal bandwidth, right? That is the advantage. The bandwidth requirement as compared to you can talk about the DSB and AM, from both of them its bandwidth requirement is half. So its bandwidth is FM, that will be 4 kHz. Answer is A. What is the main challenge of SSB modulation in practical application? What is the main challenge? Okay, so whenever you are drawing when you are modulating the SSB signal, there are 2 methods to generate the SSB: frequency discrimination method, and another one is phase discrimination method. In frequency discrimination method, we are requiring the filters. To make a ideal filter, we required high complex filters, you can say, because we can't make a ideal filter. You can go for Butterworth filter. As you increase the order of that one, that will go towards the ideal one, and its complexity is increased. So basically, if you are generating the SSB modulation signal, we require a complex and expensive filtering. That is the main requirement here, right? That's why we are not generally use the SSB in practical cases. That is the main challenge. Which modulation technique is commonly used for SSB signal? Demodulation technique. See, whenever you are discussing about the demodulation, the coherent detection is used for DSB-SC and the SSB. So answer will be coherent detection. In the SSB system with the upper sideband transmission, if the carrier frequency is 1 megahertz and the highest component message component is 5 kilohertz, which frequency will be present in the transmitted signal? See, whenever we are talking about the which one, this is SSB signal. If you draw the spectrum and we are transmitting only upper sideband, so this is your carrier and upper sideband is FC plus FM. Right, we are transmitting only upper sideband, that will be FC plus FM. So what frequency component will present? FC plus FM. FC is 1 megahertz, so 1 megahertz we can write that 1000 kilohertz plus 5 kilohertz, that will be 1.005 megahertz. That will be the answer. Next, angle modulation include which of the following type of modulation? See, whenever we are talking about the angle modulation are two types: phase modulation and frequency modulation. Phase modulation and frequency modulation are the type of angle modulation. AM, DSB and SSB are the type of amplitude modulation, right? Remember that thing. Next is in frequency modulation, FM signal, if the frequency deviation is proportional to, see, if I am talking about the FM signal, the frequency deviation is represented by delta FM, so delta F, that will be KF into AM. So it means the maximum frequency deviation is delta F, which is directly proportional to the message signal amplitude. So what will be the answer? Amplitude of modulating signal. Next, what is the main advantage of frequency modulation over amplitude modulation? If I am talking about the advantage, the major advantage of FM signal is that it is highly immune to the noise. It is highly immune to the noise. Remember that thing, right? So better noise immunity. See, if I'm talking about the practically, you can see, if you have heard about the AM band. In AM band there are several noises are there, and when you listen the FM radio, there is a you can say voice quality is better as compared to AM. That is why, because it is highly immune to the noise. There is very less noise in FM. That's why we are using the FM, right? Because whenever you are listening the music, there is bandwidth requirement. If I am talking about bandwidth requirement of FM is higher as compared to AM, but it is you can say the immune to the noise. It is higher immune to the noise. That's why we are practically using currently FM. AM signals are mostly suppressed there. So what will be the advantage? It is higher power, no, it is better immune to the noise. Smaller bandwidth, no. Bandwidth requirement, I already told you, bandwidth requirement of FM is higher as compared to AM. Higher power efficiency, simple receiver design nahi. But other thing is not correct, only the better noise immunity. In a phase modulation, the phase deviation is directly proportional to. In phase modulation, if I am talking about the phase deviation, that is delta phi, which is equals to Kp into AM or Kp into MT, you can say. So it will depend on the amplitude of a modulating signal. The answer will be amplitude of modulating signal. In the previous case, he is asking about the frequency deviation. In this case, he is asking about the phase deviation. So phase deviation is also directly proportional to the message signal amplitude. If the modulation index of FM signal increase, what happened to bandwidth? If I am talking about the Carson rule says that bandwidth of FM signal is twice FM 1 plus beta. See, what happen if you are increasing the modulation index, so your bandwidth will also increase with the factor of beta plus 1, you can say like this. So whenever you increase the beta, then your bandwidth will also increase. If the frequency modulation, how does the bandwidth of a multi-tone modulating signal compare to the single tone? Single tone means whenever you are modulating a FM signal with a single sinusoidal wave. Whenever you have a multiple sinusoidal wave, that is multi-tone. So if you have a multi-tone modulation, it means your bandwidth requirement will be increased. So what will be multi-tone modulation? Frequency required more bandwidth than the single tone. So what will be the answer? That will be B answer, right? The next question. What is the primary advantage of FM stereo multiplexing over mono FM transmission? Mono FM transmission, and when you compare stereo multiplexing, so basic advantage is the ability to transmit left and right audio channels separately. That is the advantage of this one, right? Next, in the indirect FM method, indirect FM generation method, that is called Armstrong method, what role does the phase modulator play? See, whenever I am talking about this Armstrong method, this is the method to, this is indirect method, you can say. This is the indirect method to generate a FM signal. What is happening inside that? If you have a Armstrong method, so first we generate a narrow band FM whose modulation index is very less. We convert that narrow band FM by frequency multiplier and local oscillator. With the help of local oscillator, we convert that a wide band FM. So the Armstrong method is just a conversion from the lower wide band FM to the narrow band FM to the wide band FM, right? And inside that one, if you talk about the role of phase modulator, the role of phase modulator is to convert the phase change into the frequency variation. That is the main thing here, right? The next question. The Foster-Silly discrimination is primarily used in which purpose of FM receiver? That is used for frequency demodulation, right? Next, in a reactance modulator circuit, that is reactance modulator circuit, which component primarily responsible for frequency modulation? See, basically, if I am talking about the reactance modulator is just a modulator in which we have a variable capacitor, right? That variable capacitor, what is, if I talking about, you have a LC circuit like this. If I am talking about, this is LC circuit, this is your capacitor, this is variable capacitor, this is L, right? And you are taking, here is the frequency or output frequency. So output frequency FR is equals to 1 upon under root of LC. So whenever I change this capacitor, if I change this capacitor, it means the generated sinusoidal signal frequency is also changed. So in this method, in this reactive modulator, what we can do, we have a variable capacitor whose capacitance is varying with respect to the applied sinusoidal signal, right? Or sinusoidal or applied message signal voltage. So basically, according to your applied message signal, your frequency will change, right? And your capacitance is changed according to that applied voltage. So there is a device whose capacitance is changed according to the applied voltage, that is called as rector diode. So rector diode is a device whose capacitance will change according to the applied voltage, that is used in the reactance modulated circuit, right, where we can generate the FM signal. Next is primary purpose of pulse code modulation in digital communication system. See, basically, if I am talking about the PCM system is generally a method to convert a continuous time signal into a digital signal 0101 form. So this is a conversion of analog signal into the digital form for efficient transmission. That will be the answer here. Next one. Which of the following is not the step of involving in PCM system? See, if I am talking about the PCM system, first step is sampler. Second one is what? Second one is quantizer. And the third one is encoder. So there are 3 steps in your pulse code modulator system. First is sampling. So sampling is just convert the continuous time or analog signal into discrete time. Quantizer will convert that discrete time signal to you can say discretizing in its amplitude also, and encoder will provide the code of each one. So sampling, quantizer and encoder are the part of that one. Modulator is not the part of, is not a part of PCM system. Next, according to the Nyquist theorem, what is the minimum sampling frequency of a massive signal with a maximum frequency of 5 kHz to avoid aliasing? See, to avoid aliasing, what we can do? Avoid aliasing, the sampling, Nyquist sampling theorem states that Fs should be greater than or equals to twice of Fm, twice of massive signal frequency. So what is the massive signal frequency? That is 5 kHz. So Fs should be greater than or equals to 10 kHz. He is asking for the minimum. Minimum means equality. So Fs is minimum value is 10 kHz. So basically, whenever I talk about the Nyquist sampling frequency, if he is asking for the minimum frequencies, you just have to use the equality. So what will be the minimum frequency? That will be 10 kHz. Next, in PCM, increasing the number of quantization level reduce the result will be increase the quantization noise, reduce the quantization noise, reduce the bandwidth, increase the sampling rate. Let us discuss. See, basically sampling rate is not depend on quantization, that will be depend on the massive signal frequency or that one. This constraint on the sampling frequency. So the sampling frequency will not depend on, I am again saying that thing, on the step size or you can say the number of levels and anything. Okay, next thing, if I am talking about the step size is V peak to peak divided by number of levels. So this term is called as step size. If I am talking about the maximum quantization error, the maximum quantization error is delta by 2. Remember that thing. So if I increase the number of level, the delta will be decreased. So it means your quantization error will be decreased. If you increase the L, the bandwidth requirement of a PCM system is NFS by 2. So if I increase the L, you means N is the number of bits per sample. So that will be N is equals to log 2 base L. So it means what happen, we are increasing, when we are increasing the L, we are increasing the N. When you increase the N, the bandwidth requirement will be increased. That is the relation here. So what will be the answer? Increase the quantization noise? No. Reducing the quantization noise, reducing the bandwidth? No. Because these two cannot be answered. These two things are increased. In PCM system, use a 8-bit encoder. It means N is given to you 8-bit and he is asking for the quantization level, that will be 2 raised to power 8, that will be 256 levels. Okay, next. What is the primary advantage? What is the primary advantage of digital communication over analog communication? See, whenever I am talking about the digital communication over analog communication, the digital communication is again more immune to the noise as compared to analog communication. So that's why we are shifting towards the digital communication. So what will be the answer? B will be the answer, highly immune to the noise. In digital communication, the purpose of converting an analog signal to the digital signal is called as whenever you convert a digital signal to analog signal to a digital signal, there are two things, that is sampling and quantizer. So what will be the answer? C. I already discussed this thing with you. What does the Nyquist theorem state? That the signal with bandwidth B. See, whenever you have a signal with bandwidth B, the Nyquist theorem says that the sampling frequency must be greater than or equals to twice of B. So must be, rate should be equals to B, rate should be at least equals to twice of B. That will be the answer. In a PCM, increasing the number of quantization level will increase the quantization error. I already discussed this thing. If you increase the L, it decreases the quantization error. This question I think it is repeated again. Okay, no worry. The term bit rate. See, bit rate means whenever I am talking about the bit rate, every time the bit rate is defined as the number of bit transmitted per second. How many bits you are transmitting per second, that is called as bit rate. So what will be the answer? The answer is number of bit transmitted per second. That is answer is A. Next, in a binary communication system, the probability of bit error rate is defined as, see, whenever we are defining the bit error rate, so there is a relation. If the bit error rate BER is inversely proportional to the SNR. It is not the exact inverse relation, but whenever you increase the SNR, the bit error rate will be decreased. Every time remember, there is an inverse opposite relationship between the SNR and the bit error rate. That will be in the form of, if I am talking about the bit error rate directly proportional to the Q function of SNR, right, like this, something like this. That is the relation. But remember one thing, there is a opposite relation between SNR and bit error rate. Whenever you increase the SNR, bit error rate will decrease. So what will be the answer? Lower the transmitting power. See, the binary bit error rate will increase, it means SNR will decrease, right? Bit error rate increase, SNR decrease. SNR can be decreased by two things. SNR is decreased. SNR is what? Signal power upon noise power. So there is two things. Either we can increase the signal noise power, either we can decrease the signal power. So higher SNR, no, SNR should be decreased. Lower noise power, no, noise power should be increased. Lower transmitting power, that will be the answer. Higher the bandwidth, will not depend, the bit error rate will not depend on the bandwidth. It is only depend on the SNR. What type of encoding technique assigning a unique code to each symbol? See, whenever we are talking about the information theory and encoding, there is every symbol will assign a unique code, right? That unique code will be given by source coding. Source coding, there are several source coding algorithms which we can use to assign a single code so that we will receive effectively, right? The purpose of channel coding is, see, whenever we are doing the channel coding, the main purpose is channel coding to improve the error detection and correction. That is the main thing. Whenever you are imposing the channel coding algorithm, their main purpose is what? To improve the error detection and correction. Which modulation technique is primarily used in digital communication? See, basically, if I am talking about the digital communication, in digital communication, the PSK, phase shift keying, is mostly used. Remember that thing. Mostly we are using the phase shift keying. FM is analog communication, AM is also analog communication, quadrature modulation, quadrature amplitude modulation is also a part of AM signal. So we can say the phase shift keying. In a BPSK system, how many phase state are used? See, if I am talking about the BPSK system, in BPSK system means binary PSK system, we have two signal. Either we have 0, either we have 1, right? So for 0 we are transmitting 0 degree phase, for 1 we are transmitting 180 degree phase. So we are changing the phase according to the applied bit. If 0 will come, we will directly transmit to the carrier. If we have 1, we change the phase of the carrier by 180 degrees, so that we will differentiate between 0 and 1. So there are two phases. Answer is B. In a communication system, intersymbolic interference is caused by. So whenever you talk about the intersymbolic interference, it is meaning that we are transmitting 2 bits like this, 2 or 3 bits like this, any bits. And if you talk about its spectrum is what? Its spectrum is sampling theorem. Sampling function, right? When you take its Fourier transform. If I truncate this, right, now you are transmitting this pulses through a band limited channel. So that band limited channel will crop this one, will remove the higher side bands. Whenever you are compressing a signal in one domain, then it will be expand in the other domain. So this signal will also expand, this will also expand, they will also expand. So they will start overlapping with each other. This overlapping is called as intersymbolic interference, right? So basically this is due to multipath propagation. Shannon capacitive formula gives you maximum data rate of the channel in terms of, if I am talking about the Shannon capacity theorem, that will be C is equals to B log of 2 base 1 plus SNR. So in the form of bandwidth and the SNR, signal to noise ratio, and the bandwidth. Answer is C. See, in the BEL exam, mostly question I'm talking about, mostly question are straightforward. So that's why you have to go through all these questions. Mostly questions you can see that nearby these one will come in your exam. So which technique is commonly used for error detection in digital communication? So if I talk about the digital communication, there is error correction. Error correction will be done only by the CRC algorithms. These are the cyclic redundancy check. Okay, what is the main disadvantage of time division multiplexing? Whenever you are doing the time division multiplexing, the main disadvantage of time division multiplexing is the synchronization. If you are taking one sample here, taking from the other sample from the other channel, third means let us take, we have three channels. You are taking first sample here, first sample here, first sample here, then you move back to the first channel and you are taking the sample from here, from here, from here. If there is no synchronization in these things, let us take two samples from here, one sample here, two sample here, there will be mixing. So the main thing is synchronization. So in TDM, what is the main thing? That is synchronization is required. That is the main disadvantage. This is the most difficult thing to capture. Quadrature, amplitude, modulation combined which of the two things? See, whenever you are talking about the quadrature, QAM is mainly the mixture of what? Amplitude and phase modulation, right? The formula for match filter to receive match filter receiver. See, whenever, okay, sorry, not that formula, that is the function. The function of the match filter in a receiver is, so match filter receiver generally do what? It is maximize the SNR, right? It maximize the SNR. So how it can do? It will adjust its impulse response according to the incoming signal, so that it will provide you the maximum SNR at its output. That is the use of match filter. Which multiple access technique is used in cellular network like 4G and 5G? That is the question. These are the important question. This is the based on current technologies. So that will be OFDMA. OFDMA is basically used in modern wireless communication to highly efficient and effectively utilize of your bandwidth. In digital communication, equalization is used to, see, whenever we are equalizer will be done at the receiver side. So what it will do, equalizer will reverse the effect which is provided by the channel. See, sometime whenever you are transmitting through the channel, the channel will distort your signal, so it will compensate the distortion of the channel. That will be the answer. So what is the distortion introduced by channel? The equalizer will be reverse that effect. Okay, next, what is the primary advantage of differential DPCM? So in DPCM, or not DPSK, sorry, that not DPCM, that is DPSK. What is the primary advantage of differential phase shift keying? See, in differential phase shift keying, there is no carrier requirement, right? There is no carrier synchronization requirement. That is the main advantage of this one. So it is easy to implement. It is easy to implement without carrier synchronization. That is the main thing. Power requirement, higher bandwidth efficiency, higher data rate, that will be same as compared to the other, right? Next, which noise type primarily affect your digital communication? See, if I am talking about the noise, that will be thermal noise. Thermal noise is everywhere. Whenever you are using any electronics instrument, that will introduce the thermal noise. Impulse noise, it is also there. Quantization noise is also there in digital communication, because whenever you have an analog information, you are converting that into digital, that there will be a quantizer. So quantizer will introduce the quantization noise. So answer is all of the above. Next, the autocorrelation function of a random variable xt. See, whenever I am talking about the autocorrelation function, there are several properties of autocorrelation function. Autocorrelation function is an even function, first thing. Second thing, autocorrelation function is always maximum at tau equals to 0. It is having maximum value at tau equals to 0. That will be remembering the thing, right? Next is, which of the following property is true about the power spectral density Sx of x? See, every time whenever you are plotting Sx of f, that will be non-negative, always lying above the signal, right? It is not periodic, it is maybe periodic or may not be periodic, but one more thing, it never be negative, because the power of any signal cannot be negative. That's why it is real and non-negative. What will be the answer? Real and non-negative, right? Next, autocorrelation function and power spectral density are related to each other. See, whenever we are talking about the relation between autocorrelation function and power spectral density, the power spectral density is the Fourier transform of autocorrelation function. Remember that thing. It is a Fourier transform pair. Next is white noise signal. White noise signal is defined as whose power spectral density is constant over the interval from minus infinite to infinite. So it is having a constant over all frequencies. So its answer is G. Next, the output of a linear time invariant system when a random signal is the input depend only on. See, whenever you have a random signal at the input, let us take, we have h of t here, and this xt is a random signal and output is yt, right? So the basic output is yt is generally xt convolution with ht. If he is talking about the output, every time if you have a LTI system, only the input signal, no, only the system impulse response, now convolution of input signal and its impulse response. So whenever you have a LTI system, its output is just the convolution of input and the impulse response, right? It is all about the output, not about the output power spectral density. That will be different. Next question, what happened to the power spectral density of the signal when it is passed through the system? See, whenever you are passing through a random signal through a LTI system, output is yt, then sy of f, power spectral density of f, that will be mod of h of f square into sx of f. So what will be the answer? It is become 0. It is scaled by the magnitude square of the system frequency response. So that will be the answer. You know that thing. Okay, next. If the input autocorrelation function of a LTI system is Rx of tau, the output autocorrelation function is, the input autocorrelation function is Rx tau, the output autocorrelation function is the same as the input no, convolve with the system impulse response, convolve with the system autocorrelation function. See, basically you have a system ht, input is xt, output is yt. So whenever we are talking about ry of tau, that will be h of tau convolve with h of minus t, h of t, h of minus t in convolution with Rx of tau. So generally what we can say, this is the convolution, this is the Rh of tau convolution with Rx of tau. That will be the answer. So the convolution of, it is the convolution with the system autocorrelation function, right? It is a convolution of system autocorrelation function with the input autocorrelation function. Then you will go to the output autocorrelation function. The properties of white noise. The properties of white noise is what? See, whenever I am talking about the white noise, its power spectral density Sn of f is equals to n naught by 2. If you take its inverse Fourier transform, Rn of tau, that will be n naught by 2 del of tau, right? The first thing, the property, a property of a white noise, first thing, its autocorrelation function is an impulse function. That is correct. Its power spectral density is impulse function. No, it is a constant throughout all the frequencies. It is zero mean. It is always zero mean. That will depend on the things where we applied. Its mean is may be 0 or may not be 0. It is having infinite energy. That is not also correct. Answer is A. Next, which of the following statement is true for the output of LTI system whenever white noise is applied at the input? See, whenever you applied the white noise as the input, the the output power spectral density Sy of f is how much? Sy of f is how much? That will be mod of h of f square into Sx of f. Sx of f is n naught by 2. So output power spectral density n naught by 2 h of f k mod of square. That will be output power spectral density. The output power spectral density depend on the system frequency response. That will be the answer is C. Next, a stationary random process. Which of the following statement true about the autocorrelation? Whenever you are discussing about the stationary process, so stationary process autocorrelation function is only depend on the time difference or tau. So answer will be B. Remember that thing. It is not a function of t. It should be a function of time difference. T1 minus T2. It should be a function of T1 minus T2. That will be called here tau. Okay, next. Werner's theorem states that the power spectral density of a stationary random process is a Fourier transform of the autocorrelation function. So I already discussed you what is the relation between the autocorrelation function and the power spectral density. They both are the Fourier transform pair. So this theorem tells you that this Werner theorem will tells you that your power spectral density is the Fourier transform of autocorrelation function, right? That is only applicable for the stationary process. This is the question, what is the autocorrelation function for the random signal xt? Xt is a cos square twice of f naught t. See, basically whenever you are finding the autocorrelation function, the rx t1 t1 t2, let us take t1 t2, that will be integration minus infinite to infinite x of tau plus t d tau. So whenever you replace all these values, so what you will quote? Integration. So basically not infinite to infinite, this is a periodic signal, so we are doing the integration for one period 1 over t. So integration 0 to t, that will be a square is coming out, a square cos of 2 pi f naught t1. Either you can let t1 and t2, either you can let t1 and t1 plus tau, it will depend upon you. Then it is cos of 2 pi f naught t2 d tau. Whenever you apply it cos a cos b, then it is going to be a square by 2 outside and integration 0 to t, then it is become cos of 2 pi f naught, right? T1 minus T2, that will be, let us take tau d tau, and other one becomes 0. So whenever you integrate this, so you will got that your value is 1 over t also there. So t to t cancel out, a square by 2 cos of 2 pi f naught tau. So it should be a square by 2 here, right? To be answer. That is the periodic nature. Next. If the input to a LTI system is a white noise, constant power spectral density, the output power spectral density I already discussed, that is n naught by 2 mod of h of f square. Which of the following is the key property of a autocorrelation function? Autocorrelation function is always 0 for tau, that is not correct. Autocorrelation function, I already told you, that is an even function. That is the correct thing. Even function means it is symmetrical about y-axis. The Rx tau is complex and real function? No. Complex for real signal. Rx tau is a odd function? No, that's not so correct. It is an even function. The power spectral density of a signal passing through a ideal low pass filter, right? Ideal low pass filter is what? It is scaled by h of f over entire frequency. No, 0 outside the frequency bandwidth, because we are passing through the low pass filter. So low pass filter only pass the frequency up to fc. So what is the answer? Outside the filter bandwidth, the value will be 0. Constant for all frequency? No. Invented compared to the input power spectral density. The answer will be B here. For a random signal xt, the area under the autocorrelation function represent what? See, whenever we are talking about the area under the autocorrelation function, that will provide you what? That will provide you total power of the signal according to the Parseval's theorem, right? Next one is white noise said uncorrelated, because white noise is always said be uncorrelated because its autocorrelation function is a impulse function at the origin. So answer is B. The PST of a random process xt is this one, the total power. Whenever you have a PSD, so you can find the total power. Total power is P total power is integration minus infinite to infinite s x of f d of f. So whenever you integrate from minus infinite to infinite 5f square d of f, that is going to be infinite. So because it is f cube, when you replace infinite, that will going to be infinite. So what will be the answer? It is infinite. Answer will be B. If you have a function, if you draw this SNF, that will be a diverging function, right? Unbounded function, and you are finding its energy or power or area under that curve, that is going to be infinite. The output autocorrelation function of a LTI system will give convolution with the Fourier transform. That will be the Fourier transform of R of yt. Don't go for this one, because this is h of f. It should be autocorrelation for the function of the impulse response. Fourier transform of h of f, that is not correct. Rx of tau, that is not correct. Only the Fourier transform of the power spectral density of the output, not Fourier. That will be inverse Fourier transform. That will be inverse. That is a printing error here. That will be inverse Fourier transform of Sy of f. Remember that thing. The Gaussian random process passed through a LTI system produce the output. See, whenever you have a Gaussian process and you are passing the Gaussian process through any system, the output will also be a Gaussian in nature. Remember that thing. So what will be the output? Will be a Gaussian function. Primary purpose of a mixer in a superheterodyne receiver. If I am talking about the superheterodyne receiver, the main purpose of the mixer. So main purpose of the mixer is what? Mixer combine the received signal with the local oscillator signal to produce the intermediate frequency signal. See, basically in your superheterodyne receiver, what we have to do, we have to convert all the incoming channel to a particular IF frequency, so that we can eliminate the maximum noise, or we can increase the fidelity of the system. So it will, answer will be we convert the received signal into the intermediate frequency. Intermediate frequency in a superheterodyne receiver is always less than, or you can say the fix, right? Either your channel is coming, either your coming channel is any1, your IF will be fixed. We are trying to use that local oscillator which is variable. It will convert the incoming signal to that intermediate frequency. So your intermediate frequency is always fixed. So fixed regarding to the incoming signal frequency. Answer is 6. Which of the following advantage of using superheterodyne receiver? See, it is provide better selectivity and sensitivity. If we are talking about TRF, tuned frequency receiver, their first receiver is tuned frequency receiver. Tuned frequency receiver, there is a problem that is called as selectivity and sensitivity. When we discuss about the tuned frequency receiver, we are discussing that thing in detail. So basically, if I am talking about the superheterodyne receiver, it will provide you better selectivity and sensitivity as compared to TRF, right? Tuned radio frequency receiver. So answer will be C. The local oscillator frequency in a superheterodyne receiver is typically, in a superheterodyne receiver, your local oscillator frequency is designed as it will be below the carrier frequency, right? Either it is below, it will depend on the action which you are taking. Either you are taking superheterodyne or you are taking means it the difference between the incoming frequency and the locally generated carrier difference should be IF. Either the local generated carrier having higher frequency or lower frequency than FIF, right? That is the answer. In a superheterodyne receiver, the image frequency is whenever we are talking about the image frequency, what happen when you are converting a station, let us take, you have a station here, you convert that station to the IF, but what happens, some image station will also be converted on the same frequency. So that frequency is called as image frequency. Same intermediate frequency that interfere with the desired frequency. So basically we are tune the superheterodyne receiver for a particular station, but sometime what happens, the other image station will also be converted to that IF, and that's why there will be interference created by the other signal. That signal is called as image frequency, right? What is the role of RF amplifier in superheterodyne receiver? The main function is to improve the selectivity as well as the reduce the noise, right? That is the main function of the RF amplifier. The bandwidth of an intermediate amplifier is in a superheterodyne receiver is, the bandwidth is also equals to the you can say the massive signal bandwidth, with very narrow as compared to the RF state. That is correct. Very wide. We are RF state, we are taking the wider bandwidth, so that your RF amplifier should be there and it will pass only the desired stations, right? It will not pass the station which is image to your desired station. So that is the main thing. The bandwidth of the IF is very smaller as compared to the RF stage, right? That will be the answer. Answer is A. Okay, the standard AM superheterodyne receiver, if carrier frequency, this is your carrier frequency, this is your intermediate frequency FIF, the local oscillator frequency. Remember, your FLO is always equals to FC plus FIF, right? So FC is 100,000 plus 455, so that will be 1455. That is the frequency of local oscillator, right? So remember that formula. What determine the choice of intermediate frequency in superheterodyne receiver? What choice is the intermediate frequency in the superheterodyne receiver? See, basically whenever we are talking how you can choose the intermediate frequency, that will depend on the selectivity requirement and the bandwidth requirement. How much bandwidth you are requiring, it will depend on that thing. Modulation type, it will not affect. Frequency of local oscillator will also not affect. Amplitude of incoming signal will not affect. Only the bandwidth and the selectivity requirement will affect your selection of IOF. In superheterodyne receiver, the function of detector state is 2. See, whenever you are converting a signal from a channel to a IF intermediate frequency. After the intermediate frequency, we will only pass that particular channel, right? IF will pass only particular channel. After IF intermediate frequency amplifier, after we have a receiver, or you can say the we have a receiver stage. Receiver stage will convert that signal to the massive signal back. Receiver like the synchronous receiver, that is what is the name, I forgot that name, right? There are several type of receiver which convert back your massive signal from the modulation scheme. So what is that? It convert the modulated signal into the baseband signal. So that is the use of a receiver. Everywhere if you see the detection state, detection means detector, right? So detector will convert your signal, modulated signal, to the baseband signal. Okay, these are the questions from the satellite communication. That is the important question, because this will include around 5 to 6 questions, and that will be relatively easy as compared to the other one. See, if you are talking about a geosynchronous satellite are those satellite which is stationary to a particular place. Let us take, we send a geosynchronous satellite on above the New Delhi. So that geosynchronous satellite will be settled above New Delhi every time, right? So if I am talking about its time period means whenever it complete one rotation around the earth. So its rotation should be the same as the earth rotation, right? It means it will take, if earth take 24 hours to complete one cycle, so that satellite will also complete its one rotation in 24 hours. So he is asking geostationary satellite complete one orbit around the earth in 24 hours, because it is a stationary satellite over a place. See, if he is asking about the height of geosynchronous satellite, that will be 36400. Generally we can write it 3600 kilometers. So you should remember the height of that satellite is 36,000 kilometers from the earth's surface. That will be for geosynchronous satellite. Okay, the main purpose of transponder in a communication satellite communication is, see, whenever we are talking about the transponder is a receiver amplifier. Transponder is placed on the satellite. So basically what it does, it will take, let us take, we are sending a signal from the ground station. So that ground station, it will receive to the satellite, and the transponder will receive that message, process that, amplify that message, and then again transmit to the other station where it should be go, right? So that is the main use of the transponder. Transponder will receive the message, amplify the message, and then retransmit that message to the other station. So answer will be B. Next, which frequency band commonly used in satellite communication? In satellite communication we can use Ku band, and its frequency is 12 to 18 gigahertz. So that will be widely used in your satellite communication. The period of medium earth MEO satellite, not MEO, that is MEO, medium earth orbital satellite. The MEO satellite is generally having 4 to 8 hours its period, right? They are generally rotating near the earth above 20,000 kilometers above the earth, right? So they are near to the earth, lower orbit satellite you can say, and they will complete its cycle in 4 to 8 hours. It will depend on the height where you can place that satellite. In satellite communication, uplink refers to, uplink means whenever you are sending a signal from ground station to the satellite, that is called as uplink. So signal sent from earth station to the satellite. Key limitation of satellite communication, the main disadvantage is latency. Whenever you are sending a signal, you send a signal from here to the satellite, then satellite will send back to the earth station, so it will take the lot of time. So that's why the latency is the major factor, high latency rate. What is the primary function of a lower earth orbital satellite? See, your lower earth orbital satellites are mainly LEO satellite, not MEO. That is LEO, that is all down to towards the earth, right? So mainly these are used for remote sensing and earth observation. These satellites are mainly used for that purpose, right? The orbit inclination is required for a satellite to cover the polar region. That will be a 90 degree to convert the polar region. So that will go from the polar and back like this. So it will rotate at 90 degree, right? The term footprint in a satellite communication refers to, see, if I am talking about the footprint means you have a satellite here, your earth is here. So how much area that satellite will cover over the earth, that is called as footprint of that satellite. So that is covering area of the satellite on the earth, that is called as footprint of that satellite. Next thing, the line of sight communication required. See, whenever you are doing a line of sight communication, let us take it's your earth, you are doing the line of sight communication between these two places. So what is the main requirement? There should be no obstacle in between these 2 points, right? So that your transmitter and receiver will be receive and transmit the signal obstacle free. So what will be the a direction and a unobstructed part between the transmitter and the receiver. That is the main requirement for the line of sight communication. The range of the line of sight communication primarily depend on, see, whenever we are talking about the line of sight communication, the range of line of sight communication will depend on the antenna height, right? As much as you have antenna height, you can cover the larger range. If you have a lesser height, let us take your earth is like this, your antenna is here, other antenna is here, there is no line of sight communication. So the main line of sight communication, it is depend on power also, but the main factor is antenna height here, right? Which frequency band mostly suitable for line of sight communication? See, microwave frequencies are mainly used for line of sight communication, and the maximum distance for a line of sight communication between two antenna, that will be defined by the formula twice of h. That should be not like this, that should be like under root of 2r h1 plus under root of 2r h2, or you can take like this, we can take the under root and separately, and you can write it like this. That will be the formula for the maximum distance in the line of sight communication. Line of sight communication, the fragile zone is important because, see, fragile zone is means where fractional zone is the reason where you can say your signal strength is not obstructed by any obstacle, right? It is freely go from that point to the other point. So it determines the signal modulation. No, it ensures signal strength is not affected by any obstruction, right? It is defined antenna again. No, it eliminates the interference. No, that is the main reason. Fragile zone is the reason where we can say that this antenna can easily communicate with the other antenna. That reason is called as fractional zone region. The primary application of line of sight communication. Primarily, what is the main use of the line of sight communication? That is a Wi-Fi. We can't do the satellite communication with that. Satellite long wave radio broadcasting we can't do. We can wireless communication system like Wi-Fi and other system that are called as line of sight communication. What typical range a line of sight communication will have at very high frequency? At very high frequencies, generally line of sight communication will take 5 to 50 kilometer range, right? It will depend on, mostly it will depend on antenna height and how much power you are going to transmit, right? Line of sight communication signal attenuation increase significantly due to, there are several things which can affect your signal power. See, basically whenever you have line of sight communication like this is the antenna, this is your other antenna. The first thing, whenever you sending a signal, this signal will go through the atmosphere, so some power will be absorbed by your atmosphere. Other thing is, whenever you are sending this signal, you are sending other signal, that signal is reflected by the earth, so there will be a reflection or reflection. Whenever there is a reflection, that is also you can say reflection from reflection from the earth, that is called diffraction and scattering. And other thing, let us take, you have an obstacle here, so you are sending a signal, that obstacle will reflect back that signal. So reflection from the obstacle is also the point, reflection from the earth is also the main thing, that is called scattering and diffraction. So all of these terms will affect or attenuate the signal strength of your line of sight communication. Effective line of sight communication antenna should be, see, to ensure the effective line of sight communication, the antenna should be, see, if I am talking about the line of sight communication, I already make that figure. This is so important in line of sight communication. You have an antenna here, you have an antenna here, so there will be a clear you can say allied a clear path. There will be a clear path between the transmitter and the receiver, so that will be aligned with a clear path between the transmitter and the receiver in the line of sight communication. Line of sight communication with it, the primary cause of signal blockage. The primary blockage is earth curvature, right? If your earth is flat, then you can do the line of sight communication anywhere, but earth is round shape, right? So it means whenever you are standing here, you are standing let us take 50 to 60 kilometer, then earth curvature will affect that thing, right? That is the main reason of your line of sight communication is only do for the limited range, not for the long range. Okay, GPS primary use, which type of orbit? For the GPS satellite, global positioning system. So for global positioning system, we are using for mid-range satellite, right? MEO satellites we are using. Okay, how many satellites are required for GPS to receive to determine the location in 3D? See, if I am talking about the 3D, in 3D it is required 4 satellite, in 2D it is required 3 satellite. In 3D it is required one more satellite for their time, right? Clock error correction. Okay, the signal transmitted by a GPS satellite use which type of modulation? See, whenever we are talking about the GPS is using spread spectrum techniques, spread spectrum modulation, right? What is the main function of control segment in GPS? The main function of control segment in GPS to monitor and maintain the satellite system, right? There is a the control segment mainly have a ground station which monitor the satellite health, satellite position, and ensure that the satellite will provide you timely data, right? You can say like this. Which is the approximate accuracy of a civilian GPS system? The main accuracy of a civilian GPS system is 3 to 10 meter. You generally see whenever you are using your Google map, it shows you the accuracy of 3 meter to 10 meter. So whenever you are using the GPS system, its accuracy is around 3 to 10 meter. So these are the important questions related to communication system. If you are going for the BEL exam and you want to prepare, you can join YourPedia, and these are the most important questions. Our module is launched and online classes are going on. If you want like this more session, more subject like this, you can comment, you can give me you can tell me in the comments, right? So these are the questions which are important from the communication. Let's hope next in the next lecture I think we can discuss about the signal or any other subject, but it is a really important and a good opportunity for the electronics candidate. If you are going for the gate and you want a good job and your preparation for the gate is not good, you can go for the BEL. This is the best opportunity for you.